Welcome to the demonstration of the Optics Insight tool. Hopefully you've had a chance to review the educational materials before this, and it's going to be critical to look at the raw data formatting needs before you try to upload any data. If your data are not formatted as the application here is expecting, then it won't be able to process your data correctly. Right now, I'm going to run through the tutorial data, which are always available to the application, and you can always use to test the application's functionality and also to look at what your data should look like. So your data should be uploaded in a zip file, and if you were to do that, you would do that here with this button. I'm going to select the tutorial data, which will automatically load these data that we can use to just look at app functionality. Automatically, when you load your data, the app will extract the location information about each station where you have sampling data. You can select a station by finding a station that you want to look at and click on it on the map. That will take you to the Input tab. On the Input tab, you'll be able to look at all of your raw data in time series plots as well as histograms, and it will give information about the raw data here in these tables alongside each variable. You can also select variables here. So your laboratory variable is going to be your response variable. And I only have one laboratory variable for this data set, which is total PCBs. You can also choose your predictor variables, which are your sensor data. So here we're going to use temperature, depth, salinity, turbidity, dissolved oxygen, pH, chlorophyll, phycocyanin, and CDOM to predict total PCBs. So these will be the predictor variables in the partial least squares regression. If you find outliers in your data, you can also use these slider bars to adjust the range that you're seeing in the data. So if I move this, so that updates your plot here. So now you can see your lowest number is 7.5 instead of before it was lower. You can see that I think it started at your lowest value. You can also adjust the number of bins here, so that will adjust the number of bins in these frequency histograms and make the bars wider or narrower depending on how many bins you select. You can also transform your data. Most times a log transformation is going to be the appropriate transformation to run the regression analysis. So I'm going to log transform the data here, and then they will be shown in log transform space. You can see the update in the axes here. Now let's assume that I have the data in the format that I want to run the regression. Then I will click the Run Regression button, and this will take me to the results. So up here at the top, it'll give some statistics about how the model is fitting the data. You can look at all of these to see how well the model fits the data. And then you can scroll down here to look at the sensor ranges that you selected in the previous input tab. You can look at the number of components that the regression model chose. And then this is the fit between the modeled and measured statistics. A value close to this one-to-one line is what you want, and you can see that these data, the model data fit pretty well the measured data, so you can see that the regression is fitting well. This is the total time series, so the orange line is the fitted data and the black points are the actual measured data of the laboratory variable. You can also download your results, so you would click the Save Results button, but I'm not going to do that quite yet because I'm going to go back and I'm going to change this and see if I can find a better fit. So I'm going to remove a couple of variables here. So that causes this to update the plots. Done updating, I can run the regression again. And now I can see that I have a different set of statistics. You can see the R is a little bit lower, so that means the regression fit is a little poorer. You can see the percent variability accounted for is a little lower. So this is generally not as good of a fit as the original one. And then here you can see the ranges for things for this particular regression. And then you can see that the modeled and measured values are not quite as good. So let's say I want to save these results. I push the Save Results button. And it will automatically be downloaded to my Downloads folder. Then you can go into that file, look for your results. So it'll tell you the filter limits for each of the runs, and each of the runs will have a time associated with it, so you know when you did that run. And it'll have the predicted values for that station. And then it'll have the model statistics for both of the stations, or for all of the results that you have run. And then this is kind of a nice printable high-level summary that has all of the results printed on an HTML file. So that's about it for this presentation, and let us know if you have questions.